Hey there, thanks for tuning in. My name is Eric Jensen and I'm a software engineer at Microsoft. Today I'm joined by Aaron Sternberg from Epic, who is in Unreal Engine Partnerships, and Mauricio Siglio, also from Epic, who is a director for Unreal Cloud Services. In this video, we'll be covering two topics. Aaron, Mauricio, and I will start by talking how to run Epic's Unreal pixel streaming technology on Microsoft Azure. And after that, Steve and David take over to explain what's been happening on the integration between Unreal and Azure IoT. So let's get started. Hey, Aaron and Mauricio, thanks for joining. So at Microsoft, we've seen quite a bit of excitement with pixel streaming from our customers and also our internal teams. And it would be great if you could share a bit more about pixel streaming and the value that it brings to customers.
Of course, yes. So we started working on pixel streaming about a couple of years ago with the goal of making the state-of-the-art, high quality of Unreal Engine accessible from a browser on virtually any device with no powerful hardware or software installed needed. The basic idea behind what we call pixel streaming is pretty simple. The application runs in a cloud environment, running on a powerful GPU, and the experience is delivered to the user as a very low latency interactive movie. This means that any device capable of playing high quality video supports the feature, supports pixel streaming. So since the initial launch and implementation, we received a lot of interest from the community, especially from industries such as automotive and architecture visualization. So over the last year, we decided to double down on the development of pixel streaming. And I'm very happy to say that as of Unreal Engine 4.27, pixel streaming is finally production quality. And we also support Linux, which is another major feature requested by the community. So pixel streaming together with native support for containers or Docker containers, also available in Unreal Engine 4.27, brings Unreal one step closer to being a first-class citizen in a cloud ecosystem. At Epic, we also strongly believe in the value of dogfooding our own technology. Pixel streaming is no exception, and it's the very foundation of the newly released cloud products, MetaHuman Creator and Twinmotion Cloud. We're very excited at Epic to see what cloud-based solutions the community and partners will come up with in the future. And on this note, Aaron will talk more about our collaboration with our friends at Microsoft. Over to you, Aaron.
Thanks, Mauricio. Yes, we actually had the opportunity to work with Microsoft last year on Project Anywhere alongside NVIDIA and Cesium. And Project Anywhere was an exec demo in which cloud attendees had the opportunity to explore high-resolution 3D terrain and building data in real time from any device. Let's show the clip. That's awesome. Well, a major component of Project Anywhere was pixel streaming, and we're excited to partner with Microsoft in bringing pixel streaming to Azure. In fact, the last year, we've been working together with Microsoft in enabling pixel streaming in Azure at scale, effectively making it easier for developers to quickly deploy their solution. So Eric, let's talk about what we came up with.
Absolutely. Yeah, we have some very helpful resources available to anyone using pixel streaming who want to deploy it to the cloud as easy as possible. And even if you're new to Azure or you're not a cloud developer, we've worked with Epic on documentation and quick starts to get you up and running quickly. And this can mean deploying pixel streaming in Azure on a single virtual machine or scaled out to thousands. The documentation walks you through each step to manually set up pixel streaming in Azure, which is a good first step to understand how it all works. And then when you're ready to scale out your game or app, we've released a tailored solution in GitHub. And that takes the great work Epic did on the matchmaker and the signaling server with some tweaks and automation. So that with some minimal configuration, you can now deploy hundreds or even thousands of streams to Azure globally using Terraform.
So this Terraform solution is essentially automating all the work you'd have to do if you were a developer trying to manually spin up numerous streams in Azure, right?
Yeah, that's exactly right. So, just some background. When we started looking at pixel streaming, it was certainly easy to get a single stream up and running. However, for internal and external customers who wanted to run any number of streams, essentially using the elasticity of the cloud, that's when more work was needed. So think about building a pre-baked image with all the tools in the framework pre-installed, scripting to pull down and deploy the Unreal app and the matchmaker and the signaling server, making sure it's running on restarts and resets, virtual machine scale set integration for scale, traffic manager integration for global deployments, auto scaling options for elasticity, etc. So as we started building out all this complexity, we realized it would make sense to release all this work for our customers. And it would essentially save developers hundreds of hours of work it took us to get it right. So this is where Terraform, which is a tool that is used to manage deployments on-prem or in the cloud, helps us to deploy the whole solution in Azure with a few commands. Let's maybe quickly walk through and share what documentation we have and what it takes to deploy Unreal Pixel Streaming in Azure. So grab the browser, Azure Pixel Streaming, okay, top result. And this brings us to our to the documentation. And as you see, there are 3 pages, where the first one, we are talking about the key components that make up pixel streaming. It's talking a little bit about the different types of architectures that we have, running it on a single virtual machine, running it on multiple virtual machines, but in a single region, or running this multi-region. The second part is about deploying all the pixel streaming constructs manually. So this walkthrough will give you a really good understanding about all the moving parts, about what's going on under the hood, how this is deployed onto Azure, what kind of resources you need in Azure. And after you've done this, you really know everything that makes up pixel streaming. This is a task that's doable, but not at scale. So that's where the third one comes into play. And this is where we walk you through the GitHub repository that we've created with all the additions that we talked about earlier, and talks you through how to set this up, how to configure it, and how to deploy it. And that's essentially also the only 3 steps that you need to do. So fork our repo, that's easy enough. Change some of the configuration in Terraform. Think about the regions that you want to deploy to, the amount of GPUs that you want to deploy to, the auto scaling settings that we've enabled in the solution. So how aggressive do we need to auto scale? These kind of things. Obviously, don't forget to copy over your own Unreal application and push it to your repo. And once you've done that, it is essentially a Terraform, init, validate, and apply. And 15 minutes later, you'll have your deployment running, no matter if you selected a single virtual machine in a single region, or if you're deploying this into 5 regions with 20 or 100 nodes. So let's have a look at one of the deployments that we've done before. As you can see, this will send me to the traffic manager. This deployment is done in both Western Europe and Central US. Both regions have got 2 streams available to them, so 2 GPUs, so 4 in total for this deployment. When I will click this, I will go to the traffic manager URL, so the global DNS load balancer, and that will redirect me to the closest data center. Now, since I'm in Amsterdam, that's going to be Western Europe for me. So let's have a look. Let's go in. Let's start the Webrtc. Okay, here I am in this Unreal world, walking around, and there's some bad guys here trying to attack me. And the great thing about this is obviously that this is rendered in a remote GPU, not on my own box, and we're streaming the frames live here. at full HD using 30 frames per second. Now, there's something else that hasn't been released for pixel streaming that we've been working on together. Do you think we're ready to talk about it yet?
I believe so. So originally, when we started looking at options for pixel streaming in Azure, we wanted to have the easiest way for developers and creatives to get their content deployed without worrying about the infrastructure piece. So while the open source version of deploying pixel streaming in Azure with Terraform was a step in the right direction, in collaboration with Microsoft, we are happy to announce that Epic Games will be providing a solution in the Azure Marketplace to help deploy UE applications in the cloud at scale. The powerful thing with the Marketplace solution is you can simply upload a zip file of your UE4 game or app via the Marketplace, choose your customizations to desired scale, and Azure deploys your solution within minutes at whatever scale you selected. This could be one stream or thousands. So we're all working hard to get this done by the end of the year. Eric, other than the added simplicity this provides for deployment, can you share with our viewers some of the additional functionality this solution will have over the current Terraform deployment we've been talking about?
Yeah, it's a decent upgrade, as the Azure Marketplace version has an added management portal with lifecycle management, an API for additional integration options. Because, well, you know that once you deploy the Unreal app, it's likely that there will be changes or tweaks to the app, and the lifecycle management adds the ability to just upload the latest binaries and roll out the new version to all your nodes, including any new configurations to scale, frames per second, streams per virtual machine. Besides that, we've also added options for HTTPS, custom domains, and authentication to the Unreal application for scenarios that require a user to be logged on to see the app. And lastly, for operational purposes, we've added a dashboard that shows you the usage, the health, and the scale settings of your global deployment on a single page. I know we are certainly looking forward to seeing the launch of pixel streaming in the marketplace by the end of this year, and feel that this will make a huge impact in the experience developers and creatives will have in deploying pixel streaming in Azure. Aaron and Mauricio, thanks a lot for joining me today. And now we'll go over to Steve and David and listen to what they've been doing on the Unreal Engine front for Azure IoT integration.
Yeah, thanks, Eric. We definitely have some amazing things happening around digital twins and IoT in Azure. The Internet of Things is a big step forward for the industry in terms of our ability to measure, monitor, gain visibility into the operations of customer assets and processes from across the world. Digital twins and the Azure Digital Twin service specifically takes those capabilities to the next level, allowing you to take your IoT and other critical sources of data and add business context to it and model it in a way that more closely resembles, the real world around you. The joining of this logical view of the world overlaid with the physical view can be a powerful combination. Speaking of physical view, joining me today is David from Epic Games. We'll share more about what Epic Games is doing in digital twins.
Thanks, Steve. It's good to be here, and a great lead into where and why people are looking at game engines as part of their digital twin solutions. And I guess by part of their solutions, I mean creating the user experience for digital twins is probably a better way to put it. Because Unreal Engine isn't, we're not a data platform. Its core value proposition is its real-time rendering ability to create these unique applications that bring people together in this collaborative, immersive experience. And this is something we've been doing in the game industry for a long, long time. And more recently in the architecture, engineering, and construction spaces, we've just seen some great customers take the engine to aggregate data from a variety of different sources to share and showcase with stakeholders or their customers, and include even IoT data into these experiences. So this ability to create a customized experience for people in what they see and how they see it is where we're adding value to the digital twin conversation. And, our goal is really to give a user-friendly window into that very sophisticated IoT backend. So I'll just quickly keep on going from here and just explain maybe what I mean about this, just to explain it a little bit better. And I can even show some quick examples to show it in context. And an example would be in maybe city and urban planning. There are really vast data sets available to the public. And these data sets, they're free and they're usually in open source locations. However, the data sets are not always stored in a way that we can make use or that is accessible to the end users, the citizens of the city. Whenever they're in a web API or a specific JSON format, that's not something we can all access. So one of the examples is Build Media, which is this architectural visualization firm in New Zealand. And they've worked with the Wellington City Council to not only contextualize the data in a 3D world, but bring in all these different sources from GIS to BIM to IoT so that citizens can have access to see these data sets, things like live parking or bus routes or future developments of the city. And this unique ability to contextualize the data in a way that everyone can understand, whether or not you're an architect or an engineer, a city planner or not, and create these personalized user interfaces is where the power of game engines enter the digital twin conversation. And I'll share one more with you. In this other example, 51 World are utilizing the power of the Unreal Engine to manage and operate a transit station in Changsha, which is in the capital city of China's Hunan province, who were really particularly interested due to their high volume of passengers throughout their stations. They had a number topping about 2 million people a day, or roughly 25% of the whole city's population. And the digital twin is really a faithfully created one-to-one model of the station's entire underground world, which connected to the real world via sensors. And it becomes a simulation operational platform that combines technologies of digital twins, the Internet of Things or IoT, and artificial intelligence to realize the close integration of the station and the digital twin space, and making the connection between passenger flow, equipment, and management more intelligent. And 51 World has cited several Unreal Engine features as being an essential to the success of this digital twin, such as our ease of use, especially around material editing or the ability to connect visual nodes to write complex rendering logic, and resulting in a substantial increase in rendering effects or speeds of iteration. And it all really just helps in that creation of that 3D environment. But as we said at the beginning, we are but just a window into the sophisticated back-end IoT. And what I love about working with Microsoft is we have the ability to pair a powerful IoT and digital twin infrastructure with the creative tool sets from Unreal Engine to create truly remarkable digital twins.
So it's really, it's clear it's all about combining the power of real-time data with real-time rendering. But one of the challenges that we've seen or problems that we've seen from customers is they don't really know how to get started creating these end-to-end digital twin applications. Or, really kind of to put it simply, how do they get started, when they want to combine this real-time data with the power of the Unreal Engine?
Yeah, it's unfortunately a bit of a tough space at the moment. Creating digital twins and connecting IoT hubs into Unreal Engine has always required a little bit of C++ knowledge or prior programming knowledge to get them started. And if you're from the architecture, engineering, construction world, it's a high expectation that you have these skill sets at hand and available. So it wasn't really a good way forward. And it just kind of it's a barrier of entry for those users to create digital twins in Unreal, only to those who have that selected talent or skill. So our goal together with Microsoft was and is to lower that barrier of entry to allow users across the world, from architecture and engineering firms all the way to visualization agencies, to spin up digital twin applications with Unreal Engine and Azure's digital twins. So earlier this year, we awarded a mega grant to WSP, who are a global engineering firm who provides management and consultancy services to the built and natural environment, to support the growing digital twin community in bridging the gap between Azure's digital twin platform and the Unreal Engine. So imagine it as an extension to the amazing tool sets provided by Microsoft Azure that you can now link it to a 3D real-time creation platform. So Steve, do you want to take everyone through what WSP's created?
Yeah, of course. Yeah. So WSP, together with support from Epic themselves and Microsoft, this created this amazing set of resources to help users get started with their digital twins projects with Unreal Engine and Azure Digital Twins, or ADT for short. It's long-winded to say Azure Digital Twins all the time. So these tools, they range from not only the Unreal Engine ADT plugin, but like the pixel streaming documentation that Eric and team mentioned earlier, we also have a quick start sample that even if you're new to Azure, or maybe you're not a cloud developer yourself, you're hesitant to get started in that world, we can help you get started. So the sample includes an Unreal application showing a 3D model of a portion of a building, and not the entire building, just a few conference rooms, and a completely scripted installation of all the necessary Azure IoT and Digital Twins components. And we even include kind of an IoT device simulator so that you can go ahead and be feeding in real-time data and see what those results would look like. So the sample will show you exactly how to leverage this plugin to build an end-to-end scenario leveraging IoT, Digital Twins, and immersive 3D visualization.
But what's great about the plugin is it's not just about exposing the raw data values in Unreal. It's about harnessing the power of what Azure Digital Twins has to offer around what it can do with the data.
Yeah, absolutely. So Azure's Digital Twin solution, it helps you contextualize the incoming sensor data and allows more intelligent integration with both data from other line of business systems, but also how it aligns to the 3D world. So it ranges from tools to help you with that initial monitoring of the data, a live execution environment for your twin graph, as well as the ability to integrate with external data sources to populate your digital twins with data. So imagine, you have a number of sensors in a set of rooms, similar to our sample project that you'll see. We have your temperature, lights, occupancy, HVAC, et cetera. And being able to not only place those sensors within the 3D space, leveraging the 3D visualization, but also overlay things like historical data readings from those sensors over time, or supplement that with maintenance records or product specifications, all viewable and projected into this visual and immersive environment. So the relationships of the sensors, to not only each other, but also to the physical space in which they're contained, that's an important part of Azure Digital Twins. And we wanted to make that available to Unreal users with this plugin, which you'll see more of in the sample project. And maybe it's easier if we show what they've created.
Yeah, I think I can do that. Let me talk you through it and what we've got. See, the sample project showcases a small section of the WSP office, both as an imported Revit model in Unreal Engine through our Datasmith plugin, in addition to utilizing our LiDAR plugin to incorporate a LiDAR scan of the space. In addition, we put in a number of building sensors scattered through the digital environment that we mentioned earlier, things like temperature and airflow, which show real-time data straight from Azure Digital Twin platform, but using the great visualization tools of Unreal Engine, from representing, let's say, temperature, airflow using our Niagara particle system, or utilizing our lighting system, showcasing when lights are turning off and on, or even showcasing occupancy using our animation control rig to simulate when people are exiting and entering rooms. And whenever you start to see these, the list and possibilities of how you contextualize or visualize data are really endless. And I guess what we haven't mentioned is really WSP have made all of these resources completely open source and free and available to download today. So definitely recommend checking them out if you're interested in the digital twin space and using Unreal Engine for visualization.
Yeah, definitely. And the resources are really there to showcase how you connect your Unreal Engine projects to the ADT service. But then, after that, once you learn how to do it, how you want to use it from then on is, completely up to you for your own project. Anything from transportation and logistics and infrastructure projects to, warehousing, or even your, manufacturing optimization efforts.
And even renewable energy projects, right?
Especially your renewable energy projects.
I like to hear. So lastly, we can wrap up there. Before we finish for today, what's great about the Azure and Epic ecosystem is how all the different components that you've heard about today from Aaron and Eric and myself and Steve is that they can work together to deliver a complete solution.
Yeah, the ADT, an ADT solution running in a runtime Unreal application means that you can package up your digital twin app and use it with the new pixel streaming documentation mentioned earlier by Eric and Aaron. You can deploy your digital twin application to the web. This allows you to connect your digital twins to multiple users around the world, scale it up as you need to, giving your customers access to a high fidelity fully interactive Unreal Engine digital twin.
Or alternatively, you could deploy your digital twin projects using the latest immersive technologies to bring digital twins literally into the hands of your customers.
Yeah, absolutely. You can integrate your digital twins with amazing mixed reality technologies like Microsoft's HoloLens 2. We see this as being a great first step in enabling the digital twin community to harness the power of both ADT and Unreal Engine, to quickly create and deploy these digital twin apps to your customers and users. And we'll continue to work together in the future to develop these workflows.
And thanks, Steve. And if you want to learn more about Unreal Engine or how it works with the HoloLens 2, just head over to unrealengine.com and you can find out a host of different information around it. And also, we encourage you to check out the ADT plugin for Unreal Engine sample project. And the URL will appear at the bottom of the screen. So just follow that link and you should be able to find it. And lastly, I just want to voice a massive thank you to WSP and Microsoft for helping enable this journey. And we really, really look forward to seeing your amazing digital twins.